You want to try it?
Yeah.
Okay.
So up here we're saying we need a handle on whatever process is running the PMAP. And so, because later on we're going to be receiving back to this.
Down here.
Or we're going to be sending, I guess not in the receive, but in the spawn we're going to be sending back to ourselves. We're going to take a collection, which it could, I guess, be any collection that has enumerable on it. And then you're going to say, for each of these things, I'm going to spawn a thing that's going to call this function, which was the input to the PMAP. And we're going to send that, well, what happens when that thing is executed, the return value of that back to me, which was the thing that called the PMAP, with a reference to the PID that's executing it so that you can know, I guess it's like a one-to-one mapping. It'd be like which element of the collection corresponds to which result that's coming back to me.
Yes.
So then back down here in the map, we're going to map over the results of these spawns, which are going to be our PIDs. And we're going to say, I want to receive the result that matches up to that PID. So I guess it's going to go to the very first one and block. It's going to block on the very first element, because all these spawns would be fired off really quickly, presumably, if spawn was slow, for example. So it'd block on that, and you'd say, all right, the first one is finally done, and it's going to map that to the result. And then it's going to go on to looking for the second result, which may very well at that point in time have already executed because we wait for the first element.
Right, and then that's just mapping, right? So,
yep.
All right, so.
Well, it doesn't appear to run in first hour.
This does not run?
No, it does. It just.
FIFO.
I just tried it out with a large number of things. I tried some stuff out of it.
Yeah,
that's
because
expected,
you're
right?
matching.
Yeah.
Matching in
With the carrot? Seriously? Color me surprised. All right, well, give.
Yeah. So I did PMAP with like 1 to 10,000, and all I did was like IO.puts the value that comes out of it, and like the value 10,000 got printed out with like maybe 15 other values printed out after that.
I'm just wondering if it's the puts is going on, or that if you look at the actual results of the collection.
Yeah. Sorry, not to dismiss you, but for the sake of the camera, and I'm going to repeat what he said essentially, and then we can get to that after. So it's going to be almost not quite word for word, but what you said was correct, right? So the way this works is we pass it a collection that we can use enumerable on and some function for a transformation. The first thing we do is keep a reference to the current process that is running the parallel map. Then we're going to pass this collection into mapping, and for each element in this collection, we are going to transform this into a reference to a process, right? Because spawn returns a reference to a process. This is a process that has only one responsibility, and it is to run this function. This function is going to send to the reference to the current process. Current is a very bad word for this. The process that is running parallel map. It's going to send to it a tuple with a reference to the process running this one transformation and the output of that transformation. Right? So after this line of code, after this end, right, the collection is a collection of PIDs. Right? And it's kind of fun to do that with like htop or something running, because then you can see all of the cores on your machine. It's dynamic. It's interactive, at least for me. I don't know about you guys. So now we have a collection of PIDs, right? And you can see if you use htop that it's going on all the cores of your machine. So PIDs aren't super useful to people generally. So we're going to get back the actual value. And so we take this collection of PID and we map it to receive blocks. And because this is a serial mapping, like Byron said, we're going to block until we receive one particular message, which is the caret, which is the value of this PID, right? So it is this one, and the result, which was this. Once we have received this message, we don't care about the PID anymore, so we dismiss it. And this is how you implement a distributed mapping function. So all those people who say, implement distributed MapReduce in Erlang, step 1. Not that hard. This blew my mind when I first saw it. I don't know how you guys are doing.
So is there a state where the collection is a bunch of these receive blocks before the results, or virtually?
So no, because the receive blocks, right? So like when you get to this, what it ends up doing is it gets to the first element of the collection, and then it runs this function for that first element, and that becomes a receive block, which blocks until it receives a matching PID, right? And this is why I'm surprised that it would come out of order, because it's supposed to actually maintain the order.
Maybe he's passing the print as the processing function, so it doesn't get processed in order.
Oh yeah, so
the results come back.
if your print is the function, then you end up being blocked by I/O, and you're a very bad person, and you should feel bad.
Yeah, I posted the actual result that I was
Oh.
seeing, but it does seem like the values are in the correct order.
Yes.
IO gonna screen instead.
Yeah, you can't trust I/O. I mean, you're distributing and then saying, oh, by the way, could somebody please print out? And then I/O has to figure out what it can do, right? It's a valiant effort. I have made the exact same mistake multiple times. Don't feel too bad.
This would be pretty inefficient, wouldn't it? Because it's got to block the blocks on every one of these PIDs.
So in theory, yes. But in practice, all the time it spends waiting for that very first one, all the others are still doing work.
Yeah, when it goes to the second one, it's got to go through the whole.
It has to go it has to go through the mailbox until it finds a matching message. Yeah.
And then it's got to do that for every PID.
Right, so that could take a long time.
So to finish my thought, so you would be better not, if this was part of some application, it would be better to just bring them all back in and then sort them in some way yourself.
It's not. I don't think there is a concern with the loss of performance there. And that's in part, I don't want to get into it too much because this goes into how the Erlang scheduler works. But essentially it does preemptive scheduling where each process gets a share of the time that it has. So getting to here looks like you're going to end up having to wait a very long time because you're waiting for every single one of them. But in practice, by the time you get here, 3 or 4 times or 10 times or 100 times, almost all of them will be in the mailbox already. So when you receive a message, you take it out of the mailbox. So, right, yeah. A very long mailbox becomes a problem eventually. And the way Erlang handles that is by making it more expensive to send a message to that process with a long mailbox. I'm not going to get into that either because that goes into how they implement the idea of how much time each process gets, and that's just like way beyond the scope of this conversation.
Because of back pressure from the mailbox size?
So it does, yeah, it implements back pressures kind of naively that way, yeah.
Is there good documentation on how that works for later? Like, is there any good
Like
website?
what I just mentioned?
Yeah, like the actual scheduling process.
Um,
You don't have to cover here.
The book, Designing for Scalability in Erlang and OTP by Francesco Cesarini is excellent. You're going to get way more than just what we talked about in here, but it will give you a lot to look at. No! Thank you for the warning.
So I think it's the same, just to reiterate, I think with what he was just mentioning, like if the first item in your collection is, say, significantly bigger, more processing than the rest of them, your receiving map is blocking until it sees that first one, even if the rest of the spawns have already completed. But that doesn't affect, like there's no like weakest link in the chain. It's going to slow your.
So I guess, is that what you were concerned with?
I was only concerned that you're building a list of messages that could be thousands long.
Right.
And you're traversing that in a second fiddle, and as you say, it reduces slightly in the third fiddle, and you're potentially averaging a search through half of those.
Right.
Reducing,
Yeah.
when you could, visually in practice, if you're writing this in the application, you would bring them all back in and sort them really quickly.
It could be quicker, right? But, well, all right. Because this is the world of distributed computing, there isn't one answer that's going to be the correct one. Okay, just like we have jumped the shark and a bunch of other animals here. Okay.
Talking about a distributed set of answers.
Yeah, but a lot of things. Fundamentally, yes, it is a concern. In practice, this is not something you would really write yourself. You would do something like it, but this kind of distributed map work would be in practice, a lot of other things doing this kind of work. But yeah, if you run this with 1 million elements, it's going to take a long time. Although, of course, I would suggest you buy a better computer. Does anybody want a break? Apparently this group is doing very badly at breaks, so I'm just checking. Sorry? Well, we kind of walked through it. I had a break, but I was standing here. This, yeah.
But isn't I mean, from what I've seen of Elixir so far, it's the entire Ruby world, and it's just the selling point is it's an improvement.
Yeah, so
forget about the process, it's just the language itself. So
if it's just the language itself, you have an improvement over Ruby in some fashion, yeah. This is also the introduction to jumping into the abstractions built on top of process and distributed work that have made Erlang so powerful, right?
I'm just sort of thinking, yes, it's a selling point, but it seems like it's got a huge selling point in Wiki
Yeah.
as well. Just that it's probably more performant than Rails.
Well, yeah, so it's more performant than Rails, that's true. But if your concern is performance, then Erlang is still kind of the wrong language. I mean, granted, the Phoenix framework, hello world for the Phoenix framework is like microsecond response time, so that's kind of nice. But if you want performance, use C, right?
But not good. Use C.
Well, but I mean, the conversation about performance kind of always goes towards more performance, more performance, more performance, right? Yeah, it's better. There's no denying that. It works better.
It's reasonable performance.
Okay, well, if you want reasonable performance, yeah. May I introduce Elixir? Yeah. And
with that example, it's like your function, you're expecting it to be kind of like taking some time and taking some work. If you do it in sequence, you might as well put it in parallel and let Erlang kind of be blocking and switching. And
yeah.
Like it should do a lot of that for you, like multiple cores or whatever.
So Sasha, in his talk in MPEX, showed something really cool. He was just showing a very naive Phoenix web app with a very simple interface that computes the sum of a bunch of integers, right? And he implemented very naively. He did a recursive function that would kind of increment up until it got to the number. So if you hit -1, it's not going to finish, right? He did it very simply to prove the point of what happens when you have a process that gets hogged that way. And because in Phoenix, everything like that is marked as a separate process, what happened is the web page got blocked waiting for an answer that would never return, right? But you could get to another web page and keep on getting answers very, very quickly. And then, of course, he went into how to debug that and find the process and kill it. But the simple idea that everything is a process, so that if something goes wrong and it crashes or it takes a long time, it doesn't affect the rest of the performance of your system, right? The benefits that I believe is the biggest one out of Elixir is that, or Erlang really, is that you have very powerful abstractions, like units of thought for building resilient and fault-tolerant systems. It won't do it for you. You can still, shoot yourself in the foot with it, but it's easier to reason about. And the tools are actually there, built into the language.
In practice, in say a typical web application, would you see any of this, or would be hidden by being explained that?
In a typical web application?
If you had to say point of the business logic and point of the
Right.
things going on, maybe you're concerned about you want things to be distributed.
Yeah. Well,
You're going to have to get down and do any of those things, abstractions above it.
I'm going to say something that probably no one's ever heard in this room before, which is, the nice thing about PHP?
I'm talking about real applications.
Well, no, yeah. Well, so the way PHP chose its implementation was to not actually do any kind of threading. It just let the web server do it, right? So when you write PHP, not only can you actually modify everything in production, which is, let's not get started on that, but you can actually, as long as your web server can process things, you can process things, right? So one thread getting blocked is not a problem for the rest of the app. And that is very powerful, right? In Rails, you can't really do that. You can, just it's more work. It's more complicated. Easier for things to break.
You just mean the memory overhead of a single process in Ruby being not the same as the Elixir process?
Besides that. Besides that, but yes.
Yeah, just fire up a bunch of Ruby processes and you got the same sort of
That's true, but those are also Unix processes which you have to fork correctly, and that's a lot of RAM, and that's, yeah. No, so if you spawn a single Rails instance, right, you spawn a Ruby process and it allocates a bunch of RAM, and it's 200, 300 megs depending on what you're doing, right? And if you want to have that work in parallel and have more of them, then you have to sort of either fork them or build separate apps that are going to talk to each other. But to fork it, it's a Unix level fork. So it has to allocate virtual memory, page, it has to copy the RAM over usually. It's more of a, it's more involved.
You said you were a sysadmin, or you still are? Or
I was.
Or did you use, did Elixir exist?
No.
Would it have been useful for you?
Not for what I was doing.
Okay.
I learned Ruby for scripting. I did some scripting to just not have to worry about overhead of tiny tasks I didn't have to do myself. But generally no. I wish I could sell Elixir to more people, but I think what he said is right. If you want something that's a little nicer than Ruby, but because you've been burned by mutable states too often, this will be a wonderful change, right? You don't have to do the process stuff at all. You can do everything in a single process. It'll still kind of be nice. It'll be testable and so forth, right?
So talking about selling Elixir, one of the big pain points with Erlang, I know when we got Erlang and Elixir, is string handling. It's
Yeah.
huge. I noticed you said it's got its own string type. Is that actually like the Erlang ones where they're all actually integers, or does it do something?
It is actually a string type. It does UTF-8. It does much better string manipulation. It does interpolation very well. And you can convert to and from Erlang car lists, or char lists, I don't know how you pronounce that, because you still need the Erlang level ones to communicate back to Erlang.
But it's not super wasteful in terms of having an integer for okay.
No.
Nice.
So we had that. Oh yeah, gen servers. Now we're talking. I realized this was a lot of me talking and you guys not typing. I'm sorry about that. But I think this was the kind of stuff that's more important to wrap your mind around than wrap your fingers around. So gen servers are an abstraction on top of sending and receiving messages. And they do that with two particular function calls and casts. And I did not put documentation there. I'm a bad person. Well, if you've seen the page for Elixir documentation, you can type gen server and you'll find the documentation. All you have to do, I could have sworn I'd written a tiny one. If you do def module something, and then inside the module you do use gen server, and then you just type n, like you close the module, you have a 3-line process that can receive messages. That's it. It's just almost no effort. You can start it, you can stop it, it has a PID. So that is the amount of effort required to start your own process that does its own thing, that becomes a unit of thought with Elixir. With Erlang, that used to be more involved. I don't know what it's like now, but back in the days with Erlang, what you had to do was essentially use Emacs. Because I think the Erlang maintainers actually wrote a function inside Emacs that you could use to paste all the actual code inside the block of you were writing, and that was how you had your gen server. So now this is just a macro up here.
So, not a macro.
Yeah, use is actually a reserved keyword, but it's a macro.
And fundamentally, what's a gen server?
Gen server stands for generic server. We're going to go into the two basic properties of it that make it generic. But essentially, it can do work and it can hold state. And that's why it's generic. It can do both those things. If you want to just do work, you would use a task. And if you want to just hold state, you would have an agent. I don't go into those because the gen server is kind of enough to show what we need. But when you write your own code, you have these options if you don't want to use a gen server for whatever reason. So the primary difference between handle cast and handle call is that handle cast is asynchronous. So when you send a cast message, like the second to last line in this slide, it means that the process that is sending the cast message is going to immediately return. Think fire and forget again. It does not care. So that's very nice. You can say, oh, some other system has to do this, but I have my own things to do, so I'll tell the system to do it, and I'll do my own thing. A call is synchronous, which means that if you send a call message, you're going to wait until you get the response. So far, so good. I artificially put a sleep of 2 seconds in there. If you were to write this code, you would see that the cast is going to return OK when you call it, when you cast it. And then after 2 seconds, you would see the inspect of whatever you passed. Call will block for 2 seconds. There's a couple of things that I need to point out here, because if you don't do that, then you will be very unhappy, because your code won't work. Handle cast and handle call are functions that have a very particular set of conventions for the way they work. They are abstractions on top of this receive, send stuff that we've seen. And in order for Erlang and Elixir to work properly, they have built data structure conventions. Handle cast takes 2 arguments, always. It takes whatever the message was, along with whatever payload the message may have had. I generally write a tuple here, but if your only message was just ping, you could just put the atom ping in there and that would be fine. And it always has the state of the server as the second argument. We're going to go into the state in the next slide, so for now just ignore it, put it to the side, don't worry, it's magic. A call has 3 arguments. It has the message and the payload, if there's one, right? Tuple is generally how you do that. It's useful. You have an element here that an argument here that I have not yet had a reason to use. It is a reference to the calling process. Essentially, this is kind of a lie, but it's close enough to the truth. If I'm going to get further into it, then we're going to get into a lot of abstractions that I don't really want to like break open yet. No. Yes, saved again. Thank you, everyone. And the last argument, of course, is the state again. Don't look at it, it's magic. The return values are also very important. Casts will generally have, well, they will both always be a tuple. Cast will generally have the atom no reply and the new state of the server, of the process, I mean, the gen server. This is the part where I stop to make sure that what I say still makes sense. Questions? Criticisms? Flames? Feedback? Praise?
What else could be? What else other than no reply would you conceivably say for cast?
Stop. Reply, no reply, stop. Those are convention atoms that you use, and when the process would exit the handle cast function, it would match on that atom and do the right thing based on that. This is why it's important. In practice, I have used stop once in a side project. I can talk about that later because I could talk about it for the next 2 hours and you would be bored to tears, I promise you. It's only interesting to me and like 2 other crazy people. Calls will generally have reply. This says, please reply to the calling process. It is possible to not reply from a handle call, but you should only do that if you know what you're doing. The next element in the tuple is the reply. It is what you send back to the calling process. And then the new state. Again, don't look at it. It's magic. Sorry, this? Yes, it could be anything. I generally will return some kind of tuple with OK and something else because I've gotten used to that convention. But it can be anything you want. Again, just don't be evil. At this point, the last thing to look at is probably this line of code. The only things to note are when you call this function start link on the module, right? When you pass the module to it, it returns a tuple, okay, and the PID of the process that started. This is assuming, of course, the process starts successfully. If it doesn't, because it's already started, you will get an error. This error is actually a tuple. Error already started. So you can match on that. This nil over here, again, is a state. It's magic. Don't look at it.
And it's already started. Can you still get the thing?
Sorry?
It's already started. And it returns.
If
This returns that it's an error. It's already started. We'll give you the thing.
it will not. It will just... no, it will give you the PID. Yes. Yeah.
What's the underscore notation?
Oh, yeah. This is a way you tell the compiler that you're not touching, you don't need this variable.
Like an optional argument?
No, just that you're not using it. Sorry? If you put an underscore in front of the argument, it's telling the compiler that you're not using it, because otherwise you'll get an error or a warning saying, you're not using this. Do you intend to use it? This from is, it's essentially a reference to the calling process. It's not quite right, but by the time you have a use for that, you'll know what it's there for. This is something that in like a year of playing with Elixir, I have not had a reason to use yet. So.
Is gen server something that's defined ahead? Are you defining somewhere? Is it an Elixir?
Gen server is a built-in Elixir module, okay. And it's actually an Erlang tool.
Concept. Okay.
Yeah.
The use invokes a macro of some kind?
Yeah.
But then you're passing that my server to a native gen server method
Yeah, so this is just a module, right? This is just a function, and this is just a module. When you do use gen server, it basically figures out, like there's code in gen server that says, okay, when I'm being used, do that. And it then is going to define a bunch of functions and such that you can use and stuff like that, and callbacks and things like that. I am just talking and talking and talking. All right, we're reaching the end of me just yammering on, I promise. You will soon write code again. All right, state. It's time to unmagic the state. Again, we have a server, and we use gen server. And then we have handle call and handle call. We have just two synchronous calls. I think I've told you before, what I showed you is bad code. Don't do it. If you're doing distributed work, synchronous messages tend to be really, really bad because they block two processes. Why would you ever want to do that? I have war stories, again, that I can tell you after, of me not realizing what I was doing. So these are two simple things. We just add a name to a list, right? And then we just transform the list of names into hello name. Okay? I'm sort of hand-waving a little bit over that because I want to get back to it after I get to the bottom. But in a high-level hand-wavy fashion, is this okay so far? Cool. You guys are awesome. So when you start the link, the second argument is the initial state. So we pass an empty list, right? So there are additional callbacks that we could use to work with the state and do things like that. I'm skipping them because they're not relevant right now. But in the English, the documentation goes into a lot more detail about this. So if you're interested, there is stuff you can read that would explain this very plainly. If you add the name Cathu over here, then what you're going to do essentially is reply OK. That's it. I'm just returning the OK. And we're going to put the name at the front of the list that is the state and return that as the new state. Because, of course, lists are immutable like everything else. So you have to return a new object. And when you're doing the call for greetings, what you're returning is a tuple with OK and the new greetings, and then the state, right? So you can do work on the state inside a call or a cast.
Is the state like in the state gets updated while some function is running? It doesn't dynamically update to the rest of that currently running function, right?
Right. If you happen to go into, like, if this were a cast, like the greetings were a cast, and it were running with Cathu and Litchard, and you added Amelie, it would know Cathu and Litchard, right?
Okay.
Because this is just a function being called with whatever the state was at the time.
It's local state.
Yeah, right. It depends what you mean by screw up. So it wouldn't overwrite one of them. If you were to do a cast or a call for greetings with Cathu and Litchard, right? When it's inside this call, it will only know that Cathu and Litchard are in the state. So if you were to add another name to it, it wouldn't know that there's a third name because it's in the middle of this already, right?
The date to state are synchronized between like states.
So if you're going to change the state like up here, this is going to be done when that particular function call is over and it returns control to the server, so waiting for the next message.
Yeah, that's what I mean. It sells several calls for some of them in any order, but one of them each.
So because they're done one at a time, right? By the time the next call starts, it will have the new state. if you want something more distributed, you need other solutions, right? Where like processes can refer to the same state or something like that. And there are ways to do it, but we're not getting into that. Because again, just deeper and deeper. Turtles all the way down. Some of them don't even look like turtles. I did write documentation. I'm not as evil as I thought I was.
Given that this whole thing is designed to really kill processes and stuff in the holding state processes, are there tools and mechanisms to duplicate?
To duplicate processes? There are ways to do it. You generally shouldn't. So the reason why, hey look, optional small break. The reason why you shouldn't is because the state is intended to be completely self-contained to the process, and you're not intended to be able to reach into the internals of the process, right? If you have a system that works and has processes like that, what you end up with is processes that have maybe their own state and then do work on new messages, right? And if you wrote tests or if you know it works, if for whatever reason the process breaks, it's almost definitely going to be something in the state that's incorrect. So you generally don't want to duplicate the state, because the state is the only reason for anything to break. You wrote your code, you have tests, right? Or at least you tested it in production or something. It's really hard to wrap your mind around that. Like I fell through that crack 4 or 5 times, going, but I want the state, but I want to copy it, but I want to save it. What happens if it crashes? Can I restart it? There are things you can do, but they're cheating. There is actually, in the Erlang documentation, there's a module called sys for system, and that has a function called getState, and you can pass a PID to it, and it will return the state of that PID. And the documentation says very clearly, this is for debugging purposes. Don't do this in production. No. No. If you need global state, then do something that is like global state. Like, well, there are solutions in Erlang for that as well. Erlang has a distributed store called Amnesia. I approve of their sense of humor, by the way. All right, so we have 35 minutes before the obligatory 30-minute break. I would suggest another 5-minute break because I've been talking at you for a while with lots of mind-bending thoughts. If you guys really want to power through, we can.
Oh yeah. Not a problem.
Oh no, that's peer pressure backwards. I don't like it. Let me take a quick look at what's coming next. Gen Service Part 2. Oh right. You guys do work now. I'm okay with this. So you can take a break, yeah. The next 35 minutes are you guys doing work. So take a break, come back, do your thing. Sorry? You do. There are implementations in the in the channel, if you want, right? Well, so to be fair, if you understand what I'm trying to get you to do, you don't need rock, paper, scissors for that. Just send messages and keep track of which messages get sent and received or something like that. But the idea is to deal with messages and then have some state that you modify with messages, right?
Yeah.
Do you? Good. I'm glad. The exercises are there because I know that's the only way to sort of get a better understanding of it, right? Yeah, it's unfortunate. Like, it's really, really hard to find exercises that are the right size and convey the right thing. So
exercises that I like to do at home with my own time.
Right.
I've got time to think about it.
Yeah.
And then experiment with things. Whereas in a situation like this, you've got to do the exercise where you're just going to get it done because you've only got so much time.
Right.
That's something to test.
So this is the only time that I'm reusing a code sample, right? Like something I asked you to do. and I generally would provide some code for it, saying if you didn't get it done, it's okay. But I figured this was probably small enough to be okay. But then, timing. Like I can't predict which questions will come in, and they're all very good questions, so I can't bat them aside.
On the slide with state, you have this destructuring syntax, but it's used in the looks like a return.
Oh, yes.
Puts two things together.
Yes, it does. If you're looking for that is a step too far back, apparently. Up is how you do it. Yeah.
Is that string concat then or something?
So this is actually saying I want to create a new list from a head and a tail.
I might have missed what you said about state, but it's not for general application state. It's just like a particular state of the process.
This is the state only for that process, yes.
And what kind of things would that mean?
Whatever you want. Like you could have the state be a string, you could have the state be a map.
So like active, or maybe like just a status of the process.
Yeah, you could do that. I have.
So just to be clear, the state is shared between function calls, but there's only one function call that has lock on that state at any given point.
You can think of it that way.
Okay.
So, okay. Oh man, I was really hoping you guys wouldn't be so smart. Cut that out of the editing. So, you know how what I showed you send and receive, right?
Right.
Well, those things are an abstraction on top of a loop of receive. It's a function that receives something, and then when it's done, it calls itself again.
Right.
So it's permanently receiving,
Yeah.
right? So the state is stored in the process. And because each message is done one at a time, it takes the process at that time, does something to it, and maybe changes it, right? So every single message is processed serially one at a time. So whatever the state is at that moment is the state it's working with.
Right, okay. Because it's that it processes something, it throws a reference to itself with the new state into essentially like a continuation space, waiting for the next message, and then that gets executed.
Yes. Yes. Getting into how it's actually implemented is it's really cool. It's really, really well done.
I'm sure it'll blow my mind, but
Yeah.
Yeah, in this example, you're basically just, every message, you're just kind of saying hello back with the state.
When you call greetings, you get a list back with, you get a tuple back with OK and a list with hello Cathy, hello Richard, hello John. Sorry,
What did that colon head name?
Oh, so that is a message. So we're part of a message. This right here, right? This tuple is a single message being sent.
Oh, that's just a message.
Right? Yeah.
How does it get to generate the number of things that can be then enumerated over? I'm just not clear how.
Sorry, how what?
How does it accumulate?
Oh, that name and state there and reply OK name state.
Yeah.
That list name pipe state close bracket, right? Is adding essentially adding name as the first element of a new list, where the rest of the list is state.
Ah, gotcha.
You were in the Haskell talk. I remember yesterday, right?
Yeah.
Do you remember the cons operation?
Sure. Yeah.
It's that same thing.
So that pipe operator is like the columns.
Yeah, right.
But in this, before we've seen it like with
As destructuring,
animation,
yeah.
destructuring, but in this case it is.
You're actually building something with it, yeah.
What's it returning that combined thing, that built up state?
This is a new list.
This new list is going where?
It's going back into the process my server. So somebody wrote hello. I'm gonna erase that. So if your process has this as the state, right? When you do add name and you have this, right? When you're done with that, your new state is this, right?
I sort of understand the state building up, but I'm just not clear.
On how it gets back to and becomes the new state?
Well, is there some magic there that's storing it in a place inside the gen server?
Yes. So when you get the return value, I guess this is line 4, right? When this function call is done, it goes back to all the code you got from use gen server, right? And you have this receive loop that receives messages. And this receive loop will have processed a message and will match on the return value. And that's going to be this reply OK name state, right? Reply OK new state, right? And it's going to know that it has a new state, so it will assign that as a new state for the process.
Yeah, so I'm saying somewhere in what we don't see in this code is some assignment thing that says gen server state equals
Yes.
this.
Yeah. That is, if your mind is okay with that, you're good for the rest of the talk, basically. It is the most magical thing that we're going to see all day. The only reason why I'm not showing you why it's not magical is because I would have to explain more than I am comfortable explaining.
Is on the first handle call reply OK. That's adding name to the state.
Yeah.
Okay.
This is
So that's the similar syntax for destruction.
It is. It's the same syntax.
Okay.
It is essentially the cons operator. So like in Haskell or in Scala, you can kind of do the same thing with the list to add something at the front or to separate it into the front and the back. Yeah.
Depending on
The head and the tail. Yeah.
Yeah, so if you're pattern matching using that syntax for structure, if you're using it within the function, you're adding.
Yeah.
And it gets added onto the front. Is there an order?
It gets added to the front. Yes.
It's a linked list.
Yes. Yeah. All right, so I have wonderful news. Apparently, the 30-minute break in 20 minutes, there will be snacks and drinks. I was thinking I would just keep you here forever, but I'm getting kind of hungry.
there a canonical way to update deprogramming structures? So like, I want to update a list inside of a
Map.
Inside of a map, yeah.
If you have nested maps, nested elements, I think map.putin will do things like this. Or it might be, it's either on map or it's on kernel, depending on how clean the stdlib has gotten. When I got started, it wasn't there.
Okay.
So, Gen server, just in one sentence, it's a module for
In one sentence.
well, whatever.
But
Just like simply so you're not repeating yourself.
I'm trying to think. All right. Are you asking about Gen server on line 2, Gen server on line, like, I don't know, 4th from the bottom, something else, everything?
Are they not? Yeah, I guess both. Yeah, so they're not the same thing. They're the same module.
They're the same module.
Use Gen server
Does something else.
Calling a function within Gen server.
Yeah. Gen server is it is the tool that you use for creating processes that follow, and I was really hoping to not say this today, that follow the OTP conventions. OTP is Open Telecom Platform,
Okay.
and that is like a big, powerful can of worms. I'm going to take you through more of OTP after this, but I'm not going to. I mean, now you're going to know.
Well, that's what
But
Erlang was designed for.
I mean, not exactly. I mean, OTP was built on top of Erlang to solve a lot of distribution problems.
Okay.
But Erlang was originally built just to have a distributed system, right? And it was built with send and receive at the very bottom and processes that you could spawn, right? And Gen server at its core is just one of those processes that can send messages and receive messages and do work and have a state, right? It just happens to have a lot of code built up around it to handle a lot of edge cases around what it means to do distributed code so that you don't have to think about it. It is, yeah. Gen server, the reason I'm showing Gen server and not just kind of building something with you, which I could do, is because you're gonna want to be using this, because this has like 30 years of software developers, sacrificing goats and bleeding and sweating on top of it.
So because when you first mentioned it, I thought it meant like generate.
No, I thought the same thing. It's generic.
It's generic server.
Yeah, as opposed to a task or an agent or a supervisor or an application.
It is generate. Like when you do Gen server start link and then you pass the module my server. I guess you're not.
When you do Gen server start link, so you're calling the function start link on the module Gen server,
You're
right?
kind of generating a server,
You're passing the module my server, and then you're creating a process
Yeah. Okay.
using the code inside my server.
Okay.
And there are OTP conventions that make that work. None of it is magic, but showing all of the conventions is, a lot. Like I could do a 6-hour workshop with people who know Elixir and go over the OTP conventions.
Yeah.
And I probably wouldn't cover everything I need to cover.
You said it could throw, like if my server was already, or you said it would throw an error. The start link could throw an error, and you're only mashing against okay.
Yes. Well, that's because I'm writing bad code. No, so, right. There are ways to do matching like this. You could do case gen server.start link do, and then if it returns OK PID or error already started, you can do various things.
Okay.
Right, like kill the one that's running or whatever. The reason I'm doing this is because I want to get in the habit of always pattern matching on the return value. I don't want to just kind of assume it's going to work, right? Because it's distributed, so how the hell do I know?
I'm just trying to conceive of a situation where it throws an error. If the server is already
So
could you call Gen server start link my server like 100 times?
Right. Okay. So I haven't covered that yet. You're right. It's a very simple answer. No, no, no! Save the day again.
Haven't missed it yet.
Now you jinxed it. So, there are, when you start a server, right, you can pass options to it after the state, right, and those will modify the behavior and the definition of the server, the generic server. One of the things you can pass is a name.
Oh, you can't have people.
You can't have something with the same name.
Is a name in it? It's in the form of an atom, I'm assuming?
Not only, yes. You will see it in the form of an atom. I'm actually going to show, there will be a slide or two where I show what the name is when we get to applications.
Maybe I should just stop asking questions and let
I mean,
let the class.
if everyone else is okay with like this, didactic line of teaching, I'm okay with it too. You prefer this? Is everybody else okay with it?
The two people who keep asking questions.
Oh, we're okay with this line of question. I mean, for those who prefer code, I have exercises, right? Like this Gen server thing is going to keep on going. There will be more work to do that will yield value. If you prefer questions, I can explain more things. Yeah, I don't want to get into what the other things can be name-wise, because that gets into other ways of referring to processes. And that is, again, more complicated, trying to build more, complex systems.
For the neophytes.
Well, I mean, if you want to see like my side project, you can start going through the code and going, what the fuck is this? What the fuck is this?
There's something. Well, I have a couple questions. Maybe slightly bike shabby.
All right.
All right. So just because they genuinely interest me, and I don't talk to any Elixir people. So right, this.
This is a good first question.
So. Yeah, this first one. So.
I'll just go back over here while you ask it. It's a good question.
So we have this genserver.call and this genserver.call can do with things. And we have arguments to it that are correct.
Yeah.
But we're in Elixir and we're in Erlang, so we're really scared about writing bugs and we want to isolate them to these processes.
Sure.
So if I call it incorrectly with something that it doesn't know how to handle, what crashes? Does anything crash? What happens?
The server receiving the message it can't handle this way would crash. It would say, I don't know what to do with this.
Like remove name.
Yeah, it would say, "Mrr."
Yeah.
So there are, at the very, very worst, you can actually just write a generic callback that will receive whatever and just do nothing with it.
Right.
In practice, if you receive a message that makes it crash, it's probably good to know that you received a message that made it crash. Because that means something is weird in the system.
The other thing that I was going to say was, so we had the sort of spawn primitive, and then we're using this genserver start.
Yes.
Cool. So I happen to know that the concurrency and distribution units are the same.
Uh-huh.
So like you have a concurrency thing where things execute at the same time, and you have the distribution thing where they can happen at the same time, but they're also on different machines.
Sure.
Which is kind of cool. So is there like another argument to spawn to say on this node, please? Or how do people do this, or do we have to get into OPSI type stuff?
So when you do self, right, that thing that you passed, right, is actually defined in the Erlang documentation as a process reference, I believe. And it can be of a couple of forms. It can be a PID, and it can be a tuple that has something like the host name and things like that. So you can ask a connected node to be the one running that code. It's really cool. It's so easy. It's so easy they shouldn't allow us to do it. We're not responsible people, we're programmers.